Hi, welcome to Scalable Prototyping. In this video, we're going to use the MAX485 module, which allows to reach communication distances over 1,000 meters, and which constitutes a great building block for creating a communication bus for our projects, based on a robust industry standard. Our goal is to send serial communication data coming from one Arduino to a different one. The first connection that we will have to make is between our serial output pin, which is going to be digital output 7 on the Arduino, and the communication module's driver input, labeled as DI. Note that we could have used any other digital output pin as long as we use it to send serial data. The purpose of this pin is to change the voltage over time in order to transmit the information. If we would measure the voltage over time at this pin, we would see the data being transmitted as a square wave, where the higher voltage at 3.3 volts represents a logical 1, and the lower voltage represents a 0. First, the data will be transmitted into one of the RS485 modules. The communication module will transmit this data across two cables, labeled as A line and B line. So the A line will be connected to the A line of the other module, and the B line with the B line. The incoming signal is first modified by the module. First, the amplitude is magnified. Then, the same signal is transmitted over A and B lines, but on one line it is inverted. The technical term for transmitting an inverted duplicate of the signal is known as differential signaling, and it's a great noise reduction technique. Let's explore how it works. Let's consider that the signal is affected by surrounded electromagnetic noise. Because the cables are close to each other, the induced disturbance will be similar on each line. So, if line A gets affected by noise with the following shape, line B will be affected by a similar noise pattern. In order to remove the noise, the receiver just needs to subtract both received signals. This way, the noise in line A minus the noise in line B will cancel out, as they are very similar. And what happens with the square pulse? Let's assume that the signal was transmitted as 5 volts for high on one line and minus 5 volts in the inverted line. The difference, 5 minus 5, would be 10. So the difference is just twice the signal. This noise protection is one of the reasons why we can achieve communication distances over cable up to 1,000 meters with these communication modules. Distances which we could not achieve if we were just using serial data directly. The receiver module finally accommodates back the signal to a voltage that our microcontroller can handle. So we just need to connect the receiver output labeled as RO to a digital voltage input. We will be using digital input pin number 6. So that's basically it. To make this work, we just need to add a few more connections. First, these are generic modules, but if we analyze the process, one of them acts as a bus driver, transforming the incoming signal and sending it through the two lines, and the other acts as a receiver, merging the two signals back together and serving the result. These modules come with two configuration pins, labeled as driver enabled, DE, or receiver enabled, RE. If they are set to high, the module acts as a driver, and if they are set to low, the module acts as a receiver. So we just need to connect these pins to our microcontroller to configure the transmission mode. We also need to add cables for the communication to go in the other direction. So we connect digital output pin number 7 to driver input and receiver output to digital input pin number 6 on the other Arduino. We can use an external voltage to power the RS485 modules, as long as it shares the same ground. In our example, we're going to use the 5 volts provided by the Arduino. Finally, we provide a ground reference to the modules, and that's it. In the next video, we will explore some example code for using this setup, and we will also analyze the signals with a digital voltage analyzer. Thank you very much for watching, and if you have any question, don't doubt to leave a comment.